Hello everyone, we are from CSEA section and this video is recorded under the guidance of Dr. M. Prasad sir. Hello everyone, this video is presented by G. Aparna, registration number 22B01A0552 and D. Navya, registration number 22B01A0537. So, in this video, we are going to talk about virtual machine. So, without any further ado, let's get this video started. Coming to the topic, virtual machine. A virtual machine is a virtualized instance of a computer that can perform almost all the same functions as a computer, including running applications and operating systems. A virtual machine is a digital version of physical computer. Virtual machine software can run programs and operating systems, store data, connect to networks and do other computing functions and requires maintenance such as updates and system monitoring. When we run different processes on an operating system, it creates an illusion that each process is running on a different processor, having its own virtual memory. With the help of CPU scheduling and virtual machine techniques, there are additional features of process that cannot be provided by the hardware alone, like system calls and a file system. The virtual machine approach does not provide these additional functionalities, but it only provides an interface that is same as basic hardware. Each process is provided with a virtual copy of underlying computer system. We can create a virtual machine for several reasons, all of which are fundamentally related to the ability to share the same basic hardware, yet can also support different execution environments. Let's look how virtual machine works. To understand how virtual machine work, it first necessary to understand the concept of virtualization and the different types of virtualization that are available. Now let's look what is a virtualization. Virtualization is a process where software is used to create an abstraction layer. This is the basis of cloud computing, enabling the creation of virtual resources such as virtual servers, desktops, operating systems, files, storage, and networks. In the illustration above, the non virtualized computer's single operating system with its drivers is in direct connection or relationship with the physical machine's hardware, and individual apps then utilize the single operating system. However, in the virtualized computer, the hardware and operating systems used by applications are separated by the virtual machine monitor, which is VMM software. VMM software enables the creation, management, and governance of virtual machines and manages the operation of virtualized environment on the top of a physical host machine. Different types of virtualization. There are many types of virtualization, including application, desktop, network, hardware, storage, data center, GPU, Linux, and cloud virtualization. For the purposes of this discussion, the following types of virtualization are most relevant. 1. Application virtualization. 2. Desktop virtualization. 3. Hardware virtualization. 4. Storage virtualization. 5. Network virtualization. Now let's look at application virtualization. Hypervisor software working in conjunction with VMM software acts as the interface between virtual resources and the underlying physical hardware. Hypervisors not only ensure that each virtual resource has access to the physical resources it needs, but also keep virtual resources from interfering with each other. By taking resources from each other or otherwise interrupting computing cycles. It's also important to note that there are two types of hypervisors. Now let's look at desktop virtualization. Desktop virtualization enables multiple desktop operating systems, each in its own virtual machine, on the same computer. This type of virtualization enables many lightweight desktops to run on a shared physical machine, which provides more user productivity with less hardware and maintenance. Now comes hardware virtualization. Hardware virtualization enables physical hardware to be treated as separate virtual devices that can be accessed over a network. One example includes CPU virtualization, which makes hypervisors, virtual machines, and guest operating systems possible. It allows a single CPU to be divided into multiple virtual CPUs for use by multiple virtual machines. Now comes storage virtualization. Disk space can be split up into smaller pieces dedicated to a virtual machine. In the same vein, a server can also combine virtual storage spaces to create much larger virtual disks. Now let's look network virtualization. Virtual subnetworks can be treated in a software network. These networks can be used to route traffic across different resources in an extensive infrastructure. Now, let's look at the types of the virtual machines. First one is system virtual machine. These types of virtual machines give us complete system platform and gives the execution of complete virtual operating system. Just like VirtualBox, System Virtual Machine is providing an environment for an OS to be installed completely. We can see a below image that our hardware of real machine is being distributed between two simulated operating systems by virtual machine monitor. And then some programs processes are going to that distributed hardware of simulated machines separately. Next comes process virtual machine. While process virtual machines, unlike system virtual machine, does not provide us with the facility to install the virtual operating system completely. Rather, it creates virtual environment of that OS while using some app or program, and this environment will be distributed and destroyed as soon as we exit from the app. Like in below image, there are some apps running on main OS as well as some virtual machines are created to run other apps. This shows that as those programs require different OS, Process Virtual Machine provided them with that for the time being those programs are running. Now, let's look at Virtual Machine Language. It's a type of language which can be understood by different operating systems. It is a platform independent, just like to run any programming language, C, Python or Java. We need specific compiler that actually converts that code into system understandable code, also known as bytecode. The same virtual machine language works. If we want to use code that can be executed on different types of operating systems like Windows, Linux, and etc., then virtual machine languages will be helpful. Now, let's look at advantages. There are no protection problems because each virtual machine is completely isolated from all other virtual machines. Virtual machine can provide an instruction set architecture that differs from real computers. Easy maintenance, availability, and convenient recovery. Now let's look at disadvantages. When multiple virtual machines are simultaneously running on a host computer, one virtual machine can be affected by other running virtual machines, depending on the workload. And the second one is virtual machines are not as efficient as real one when accessing the hardware. Now let's look at what are the benefits of virtual machine. While virtual machines run like individual computers with individual operating systems and applications, they have the advantage of remaining completely independent of one another and the physical host machine. A piece of software called a hypervisor or virtual machine manager lets you run different operating systems on different virtual machines at the same time. This makes it possible to run Linux VMs, for example, on a Windows OS, or to run an earlier version of Windows on more current Windows OS. And because VMs are independent of each other, they are also extremely portable. You can move an VM on hypervisor to another hypervisor on a completely different machine almost simultaneously. Because of their flexibility and portability, virtual machines provide many benefits such as cost savings, which is running multiple virtual environments from one piece of infrastructure. It also includes operational flexibility, which operates separate instances of multiple OS types, and also reducing overhead, which actually run multiple virtual machines on the same underlying hardware. And also, the third one is centralization, which consolidates systems to simplify management. And also, the fourth one is scalability, easily scale your virtual environment as your business grows. And the fifth one is disaster recovery. It restores the data and system states from VM instances. So, the conclusion of the virtual machine is the virtual machine is a computer file that behaves like an actual computer. It's a virtual environment that functions as a virtual computer system with its own CPU, memory, network interface, and storage. And also, a VM is an operating system or application environment installed on the software that imitates dedicated hardware. The end user's experience when using VM is equivalent to that of using dedicated hardware. A VM can run in a window as a separate computing environment, often to run a different operating system. It can also function as the user's entire computer experience. And the other thing is the virtual machine software can run programs and operating systems, store data, connect to networks, and do other computing functions. It requires maintenance such as updates and system. We can create a virtual machine for several reasons, all of which are fundamentally related to the ability to share the same basic hardware yet can also support different execution environments, that is, different operating systems simultaneously. The main drawback with the virtual machine approach involves disk systems. Let us suppose that the physical machine has only 3 disk drives but want to support 7 virtual machines. Obviously, it cannot allocate a disk drive to each virtual machine. A computer can address more memory than the amount physically installed on the system. This extra memory is actually called virtual memory, and it is a section of a hard disk that's set up to emulate the computer's RAM. The main visible advantage of this scheme is that programs can be larger than physical memory. Virtual memory serves two purposes. First, it allows us to extend the use of physical memory by using the disk. Second, it allows us to have Memory protection because each virtual address is translated to a physical address. Thank you so much for watching this video.